Welcome back. This is the last objective that we talked about in this unit. So we've done everything up until this point has been culminating so that we can graph and solve systems of inequalities. This is objective 4.9. Take a moment, write this in your notebook. If you need to pause the video as we continue. So in example 1, what we want to do is write down these two inequalities. Y is less than negative 1x minus 1. And 6x minus 3y is less than or equal to 3. Our goal today is to be able to graph these accurately so that we can find what the solution graphically is what the solution is to this system of inequalities. We're going to start by graphing this first one. I'm going to graph it with a red pen. So this is y is less than negative 1x minus 1. I'm going to graph it just like I would, start like I would as if it were a line. So I'm looking at the y-intercept is at negative 1 on the y-axis. It's here. And there's a slope of negative 1, meaning it goes down 1 over 1, down over 1, down 1 over 1. Once I've got the points plotted for this line, then I look back to see whether or not it's going to be a dotted or a solid line. The inequality is just a less than. It is not a less than or equal to. Since it's just less than, this is a dotted line. So this will do. And am I going to shade above or below? That's the next thing I'm looking at. Am I going to shade above or below the line? Since it's a less than sign, then I'm going to shade below the line. So I'm shading below the dotted line, meaning anything below here is a solution to this inequality. Great. Now I need to go ahead and I'm going to graph this second equation, but I see that this isn't in slope-intercept form, so I'm going to go ahead and change that slope-intercept form really quickly by solving for y. I subtract 6x from both sides. Leaves me negative 3y is less than or equal to negative 6x plus 3. I'm dividing both sides by negative 3. Since here I've divided by a negative number, when I go in I bring down this inequality sign, I have to flip it. And I'm left with y is greater than or equal to, this is going to be negative 6 divided by negative 3 is 2x minus 1. So I've got y is greater than or equal to negative 2x minus 1. Again, I'm going to start at the y-intercept of negative 1. I'm going to go up to over 2, as the slope tells me. Up to over 2, or down 2 back 1. Sorry, up 2 over 1, up 2 over 1, then down 2 back 1, down 2 back 1. Here's my a line that will follow. I need to figure out whether this is a dotted or solid. Since there's an equal to component to the inequality, it's going to be a solid line. So I'm going to draw a line in between. Let's see if I can do this here. So here's a solid line. Now I'm going to need to shade anything that is above that solid line since it's a greater than symbol. So use the blue. So shading anything that is above this line. Now what I'm finding is that I've got two different shades of blue here. I've got the light blue and I've got this dark blue. And the reason why it's dark blue is because it's overlapping with the purple underneath. What we see then is that this section where I have the dark blue, that shaded dark blue, is both shaded by the purple and by the blue. And that is actually the solution, believe it or not, to this system of equations, or system of inequalities, because it is a section of the graph where it satisfies both of the inequalities, meaning it's been shaded twice, it's like the double shading, then any point in this region will satisfy both of the inequalities. And we can check this by just picking a point we've double shaded. And so I'm just going to pick one point in the double shaded region. And let's pick, I'm going to use red pen here. Let's just use -2, -2. I'm going to use this point here, which is, here's the origin. Go back to, down to, so -2, -2. And that means if I substitute -2, -2 to either one of the original inequalities, it should be true. So I'm going to substitute into the first one. -2 is less than -1 times -2 minus 1. So -2, is that less than 2 minus 1? So is -2 less than 1? It is. So it works for that one. And for 6 times -2 minus 3 times -2, that should be less than or equal to 3. So this is going to be -12 plus 6. Is that less than 3? This is going to be -6, which is less than or equal to 3, and that's true as well. So the takeaway here is that that region that is we double shade, that we shade twice, actually, is the region that is considered the solution of the system of inequalities. And we can check that by picking a point in that double shaded region and confirming that it makes the inequality for both of the inequalities true. So example 2 says, which two inequalities create the graph shown? So here I've got two inequalities. Here's the double shaded region, meaning that for the solid line, I'm going to be shading above the line, and for the dotted line, that's a horizontal line, I'm going to be shading below. Okay. So I need to write the inequalities here. Let's start with the horizontal line. The horizontal line, we know, starts with y equals. And since it's an inequality, I'm not going to have equals. I'm going to have y is, and I'm shading below, so y is less than. It could be y is less than or equal to, but since it's a dotted line, I know that it is y is less than 1. So this is the line y is equal to 1. It's a dotted line, and it's shaded below, so it's y is less than 1. And for the next line, it's going to be y. The slope is 1, so something 1x. The y-intercept is 1, so plus 1. So instead of having y is equal to 1x plus 1, I need to think about it's a solid line, so it's going to be either a less than or equal to, or greater than or equal to sign. And I'm shading above this line, so it's going to be y is greater than or equal to 1x plus 1. I got the greater than or equal to from the solid line and the fact I'm shading above the solid line. So that's a greater than or equal to. This is one solution from the graph, and so I'm looking for any solution that is in the double shaded region. So that means that I could have, here's -2, 0. This is a solution, this is a solution, this is a solution. All these points here are solutions. Now the question is, are the points on this line a solution? Are they? Are they solutions? In fact, they are, because since this is a solid line, those are solutions that are included in the solution set. But are these points over here on the dotted line, are those solutions? No, actually they're not. These are not solutions since they're on a dotted line. These are not solutions. Put X's on these. In fact, those are not solutions. Alright, let's go to example 3, the last example today. It says determine whether the ordered pair is a solution for the given system. And here you have -2, 1. You know, what do you think we want to do in order to find whether or not this is a possible solution? I mean, if you thought we should just substitute in and see if it works for both solutions, for both inequalities, I definitely agree with that. So what I'm going to do is I'm going to separate this into two inequalities where I've got y is less than negative x plus 1. And into the x and y, I'm going to substitute negative 1 for x and 1 for y. If it is a solution, then the negative 2 and 1, when substituted for x and for y, should keep both of the inequalities true. Has to be both of them. So I'm going to start with the red inequality, and you're writing this in your notebook. So I'm substituting 1 for y is less than negative x, which is going to be the opposite of negative 2 plus 1. So then the question is 1 less than 2 plus 1? Is 1 less than 3? It is. 1 is less than 3, so that one's true. I'm going to put a check there. And if 1 is less than 3, that means that negative 1, negative 2, 1 is a solution for the first inequality. But this isn't good enough to know that it's a solution for the system. It has to actually work for both of them. So I have to go over here and say, when I substitute in 1 for y, is it less than or equal to 2 times negative 1 plus 3? Is 1 less than or equal to negative 4 plus 3? And is 1 less than or equal to negative 1? And actually it's not. 1 is actually greater than negative 1. So in this case, the answer is no. Now you say, but it worked for one, but not the other. That's true. This just means that it's a solution for the inequality that we found it to be true, the red one, but it's actually not a solution for the second one. So because it's not a solution for both of the inequalities in the system, it's not a solution for the system. So I hope you guys got a little bit out of this, and we'll talk more about it tomorrow. Make sure to use your notebook, and have a good night.